grab these notes from yesterday. We didn't get to them because we were working on elimination and substitution in mixed bag. Those were solving linear systems. Now what we're doing is we're solving linear inequalities. And linear inequalities have a different vibe to them, all right? But what's good, though, is you still graph them like you would a normal line, okay? Like right here, we see the inequality here. This is less. These are two less thans. Also less than, there's a less than equal to. Here's a greater than and then a less than. So they're going to switch around, okay? But if you treat this inequality as an equal sign, you can graph it just like y equals mx plus b. And we've already done that when we were doing piecewise functions, but with different subdomains. Here, you just graph the whole line, okay? So it is just a straight shot. So what I'm going to do here is I'm going to graph this as if this was just an equal sign. Now this is ready to graph because it is in slope-intercept form. This guy, not so much. Okay, both of them are not in slope-intercept form, so I'm going to have to do that. And there's also an added twist whenever you see a negative sign in front of the y that we'll get into in just a second. So let's go ahead and graph this guy. You're going to need your ruler. I'm not going to use one just because I'm privileged. So what I'm going to do is I'm going to go to -2 here. Now I'm going to choose a color, by the way. So pick a marker that's relatively light or a colored pencil. And what we do is we're going to assign a color to each one of these in the beginning. And then as you get good at this, you will drift away from the colors. Okay. So I'm going to go to -2. Okay, which is what I'm supposed to do. Go to my y-intercept. This is assumed you guys already remember this. If not, you got to remember it. Talk to somebody. And me when I return. But it's very important that you know how to graph a line. So when I go to -2, this slope in front of the x, that is my m, tells me that it's positive and it's going to go up 1 to the right 2. So up 1 to the right. If you go to the left, then you would actually make it a negative slope. Okay, and you do not want a negative slope, you want a positive slope. The 2 lines is all you need, okay? I'm sorry, 2 points is all you need. And so you're going to take your ruler and you're going to go through this. Now, here's what's interesting though. Because it's an inequality without a bar, okay? This guy has a bar here, we're going to treat him differently. This guy does not have a bar. So what you would do is you would actually draw a dotted line through the points, okay? So take your ruler and draw a dotted line because it does not have a bar. That means you can go up to it, but you can't touch it, okay? Like an electric fence. You can go up to it, it's turned on, so you cannot actually touch it, okay? All right, so that's 1. Now, what I'm going to do, though, before I graph the other one in green, I'm going to look at which direction the inequality is pointing. Now, it is a less than, because the y is isolated, I can just look at it and say less than, y is less than that line. So, if you just use your intuition, think about, of these two sides, one is greater than, one is less than, which side of this line is less than? And try to visualize. Now, it's going to be a little bit more complicated when the lines get steep because it's kind of hard to tell which one is below the line, which one is above. So what I'd like you to do is just visualize this as a staircase, okay? And so if you are looking for below it, just think of below the staircase, okay? So we're going to shade it in there just like that. Just use stripes, it's totally fine, okay? Now that is an inequality. Now what this means then is that all of the points within this color field, okay, all of these points, and I'm talking like the ones in between, the ones in the middle, the ones on the actual whole numbers or integers, okay, all those fit this situation because it isn't just y equals 1/2 x minus 2, it's everything less than that. So all of these points that are shaded actually satisfy that condition. Okay, so what we do is we go to the next line. The next line we're going to graph. Now you don't know what we're going to do with this yet or why we're doing it, but we'll get to that. But right now, we're just going to graph it just so that we can get comfortable kind of visualizing a linear system of inequalities. So let's go to +1. Now the slope tells me to go -1. Okay, I'm going to use my ruler, and again, it's going to be a dotted line. Okay, and I'm completely ignoring the purple field, okay? All right, that should be a straight line. Okay. Now, this guy again was slope-intercept form, so he's perfectly ready to go. I'm going to shade below the line, okay, because that is less than. This guy over here, right here, I might shade a greater than, okay? So it just depends. So I'm shading below the line because I want to know where I would be if I was under the staircase. This is below the line here. Okay, again, look at it like a staircase. And if it's less than, go below. Now, our solution is actually where the two colors overlap. So wherever you see the cross stitching, okay, that is actually your region. Okay, so this means my entire region here doesn't just satisfy the blue line, it also satisfies the green line. Okay, and what can happen is we can have 3, 4, 5 other lines in here, and then we just get a smaller and smaller region, and that little region, all of the numbers in there, all the coordinates, will satisfy the entire system. Now we're only going to do two lines, but there's people that there's a field called operations research where they just distinctly use like possibly hundreds of linear inequalities in their system. Now they use a computer to do that, but this is the idea. Okay, this is how they would write their programs by looking at just these basic forms. All right, now this guy's not ready to be graphed yet because he needs to be put into a slope-intercept form. So we're going to do that. So I'm going to take this guy over here, okay? All right, and I'm going to move the x over to the other side, and when I do, he will become negative. Now he's ready to graph, okay? So that's my first line, and again, I'm going to make this guy blue, okay? And the second line, okay, is a little bit trickier because I'm going to be dividing by a -2 in just a second. Watch what happens when I move the x over there. It'll become negative. Okay, now this is just typical two-step equation stuff. But now what I got to do is I do have to divide by -2. Okay, now when I divide by a -2, or any negative whatsoever, when you're dealing with any inequalities, you actually have to change the orientation of your inequality because a negative sign flips where he is on the number line. Okay, if I divide by negative, he's no longer going towards the negative direction, he's going towards the positive direction. Okay, or if he was positive, he's now going to the negative. So you have to flip his orientation. Okay, it's kind of like doing a 180. All right. So when you flip his orientation, though, you'll see that this guy is just going to, that's basically -1 there. Okay, so that is a positive 1/2 x, and 4 divided by -2 is -2. Okay, so now he is ready to graph, but notice that I did change the orientation. So it looked like less than over here, but because of the division of -2, I had to reorient myself and divide by a negative number, which flipped my orientation. So now I'm greater than. All right, so let's go ahead and do this. All right. Okay, we're going to graph these. I'm going to be a little quicker about this. Okay, so the first line is going to be +1. We got a -1 slope. And because it has a bar, he will be a solid line. Okay, so give him a solid line. All right, and it does say greater than or equal to. So I took care of the equal to. Now let's do the, did I say greater? I think I just said greater than. I meant to say less than. Less than, so that means I'm under the stairs, okay? So there's the staircase, all right? If it's less than, where would Harry Potter live? He'd be underneath the stairs. Now here, the next one, with green, I go to -2. Then it tells me the slope says up 1 over 2. And when I say over, to the right. Okay, up 1 over 2, up 1 over 2, and so on. This guy does not have, he does not have a bar, so he will be a dotted line. Okay? So, what this means then is I need to be shading now above the line. Okay? So this is where Harry Potter would not live. Okay? He would be on top of the staircase. So what I'm looking for now is the cross stitching. Okay? And they happen right in this region. This satisfies all conditions. But remember, I cannot touch this border, but I can touch this border, all right? So I'm going to darken this up a little bit, and what I can do is I can ask you a question. I can ask you, is 0, 0 a solution? Okay? And so what you do is you just say, okay, is 0, 0 in that region that I have darkened, because that's where both of the lines are satisfied. Their conditions are satisfied. And I go here, and I see that 0, 0 is right there, and I can absolutely say, yes, he is a solution in that system. He's not the only one. There's billions upon billions of solutions just in this region right here, let alone if this guy extended to infinity, there's even more, okay? So that's that. Now the only reason why I want to do 3 and 4 is these are the basics, okay? And 3 and 4 are basically conditions where X and Y are kind of by themselves, okay? So let me just show you how to do that. So now what I'm going to do, I'm going to go a little quicker now, and I'm going to say 5X, okay? And I need to have that slope-intercept form. I need to move the 5 over there. Now he's good. I can graph him. I'll show you what he looks like in a second. You probably already know, actually. Or you might move that 5x over. Okay. But now I'm going to be dividing by -3. So therefore, oh, just a second. No, so when we divide by -3 here, again, he'll become positive. But now we switch the orientation. We're going to go above the stairs now. Okay. And this guy will become a positive 5 over 3. Just leave it as a fraction because we're just going to rise over run. This guy will be also divided by -3, so that will become a positive 3. Okay, so let's graph this guy. I'm going to give him the blue. It's going to be 3. Okay, then we're going to go up 5 over 3. Okay, now if I go up 5 to the right 3, then that is going to be off the graph. So I'm going to have to go this direction, but I will have to go down 3. So I hope you kind of keep that in mind. You can go down if you go to the left, if it's a positive slope. That is possible. Now the bar didn't go anywhere. Okay. All right, and so we will be shading above this line. Okay, now I hope I didn't screw this up here. It should be good, right? +3, positive slope. Oh, no, you moved over. Yep. Okay. So that's that. And so now what I want to do, and now this is great, because when you have an x is less than -3, all you got to do, if you see an x and no y, that means what you have is you have a vertical line. Okay. And you don't have to switch anything. You just say, okay, I need my x coordinates to be -3, period. Okay. So this means that I shade everything over to the left. In fact, you can look at it as like that's the arrow that's pointing in that direction. Now the overlap is this region right here. Okay. And so if I said, is 0, 0 a solution of this, you would say no. Okay. All right. Now what if you got a y is less than 1? Well, let's graph the first guy first. So let's do this. We're going to move the 2 over there, -2, +3. And then we're going to divide by -1. Okay, division by a negative number is an issue. So y is less than positive 2x minus 3. Okay, I know I did that fast, but if you want to pause it and go in slow motion, you can do that. -3, I go up 2 over 1, bada bing. And if I make a mistake, I'm going to be really mad, but I think we're good. Okay, this guy says less than. He was greater than. Okay, he was greater than, but now we got to switch it because we did divide by -1. So I don't know if you guys have figured out a pattern with that already, but if you see a negative sign in front of the y, this guy's changing his direction. If you remember that, that'll save you a lot of time, okay? But the algebra will take you to that anyway, okay? So watch out for that negative sign. Okay, now what do you do with a y is less than 1? Well, you just go ahead and go to +1, but now you have a horizontal line, okay? And you want less than, so hopefully your intuition serves you well, and you will notice that it is underneath the line. The shading part is right here. That is where both of them overlap, okay? So now when you get to your work today, well, actually 5 and 6 are in another video because I recorded it for 5th hour. So it's going to refer to Mr. L watching the class, but just ignore that.